Okay, I think that's live. Just give me a second to get it set up. Alright, I think that we're up and about, ready to go. So today we're going to start streaming the multiple choice exam. At the moment I'm not sure how many people are actually watching, probably none. Maybe the aesthetic has worn off a little bit, but that's okay. So yeah, going to start streaming the multiple choice exam. This one's from 2016, just like the last one that I did. So I guess we'll jump into it when we're ready. All right. So first question: the most suitable graphical display for categorical data is. Okay. So I guess when you're approaching these sorts of questions, what you're going to want to do is you want to sort of rule out things to begin with. So you want to just say these questions are not going to work. I better make sure that my audio is working while I'm at it. Yeah, it is. Beautiful. Okay. So yeah, so you want to try and rule out a couple of things. So if we're looking at categorical data, that just means non-numerical. So we can get rid of stem and leaf, right? Because that's just numbers, if you remember what a stem and leaf plot is. We can get rid of box plot for the same reason. That's also numerical. There's not really any room for categorical stuff. We can also get rid of a scatter plot, because scatter plots are looking at numerical data as well. So we're left with histogram or bar chart, which is probably what most of you came down to anyway. If you think back to some of the stuff that we did in class, we talked about how one of these was better for what do you call it, numerical data, and one of them was good for categorical data. So the histogram is better for numerical, and you sort of break things up into either side of the bins, and bar charts are better for categorical stuff. So that yeah, so if you get rid of histogram, it means that bar chart's the correct answer. Okay, so bar charts are better for categorical variables than those. All right. Next says that following information relates to questions 16 and 17. A group of 50 students were asked to choose whether they would like to go to the movies, the beach, or a water park on a hot day. The results are given in the table below. A variable student choice can be described as what? Okay, so it's not if it's student choice, it means that they're choosing from these three options here. So these are words, obviously, and not numbers, meaning that you can't call them numerical data. So we can get rid of that one and that one and that one. All right, it's not numerical, it's categorical. And then we look at, is there some sort of order to these, or are they just random words? When I say order, I mean like low, medium, high, or good, not so good, etc. So they don't have an order because they're just places to go to, which means that it has to be categorical and nominal, which means no order. I'll be keeping an eye on the chat over on the side here, so if you have any questions, please ask, or if you want to comment on anything that you want me to address or fix up, please just mention it in the chat, because I'll be sort of keeping an eye on that as I go and making sure that I address anything that needs addressing. So the percentage of students that did not want to go to the beach is about what, right? So that's an easy question to misread. A lot of people read it as a percentage of people that want to go to the beach, but it's not. So if they don't want to go to the beach, you're looking at 14 and 18 together, right? So 14 plus 18 for the other two locations, not necessarily for the beach. And that'll give you 32 out of 50, right? And if you do that, you'll be able to multiply both of these by, or convert it to a percentage. So multiply it by 100, and I can tell you you'll get 64%. All right, I don't even need the CAS for that one because it's over 50, so it's pretty easy. So 64% is that. And if you notice that A is 36%, that's the percentage you would have got if you just did beach. So remember what I said when I said that the way that we write multiple choice exams is we come up with the correct answer and then think about how could you possibly do this wrong, and the other answers are always what you could have done wrong. Alright, so that's that one. Let me move this over here. Alright, next one. The following histogram shows the percentage of people in a sample with salaries between 25,000 and 115,000. Okay. Hopefully you can see that relatively well. That camera's a little bit blurry, isn't it? Let me just readjust that picture. See if it's a bit cleaner. So yeah, the amount of people in this histogram that have a salary that is less than 55,000 is about what? Alright, so first you're going to need to identify where on this graph 55,000 would be. Alright, so it's a bit hard to see, so I might zoom the camera in a little bit closer. Let me open this up and make sure that I can get a clean picture of this. Alright, so it's a little bit hard to see, but you'll notice that there's 40,000 here and there's 60,000 here, and they're at the bottom of each of these bins, which means that presumably that this one here is 50,000. Right? So if we're looking at less than 55, that means 55 has to be here on the border. Yeah? So 55 is just on the cusp, I guess, of this next bin. So if it asks what percentage of people in this sample had a salary less than that, we would just add them up. So we've got 20%, and that's probably about 25%. That's probably about 35%. So what's that? 20 plus 25 plus 35. It's like 80, I think, roughly. So that would be our answer. All right. Let's bring this back up for a second so you can see the. It's tight. Okay. I'll just make sure that that's looking at the right bit. Alright. Next question says that the shape of the histogram is best described as. So it's negatively skewed, symmetric, bimodal, positively skewed, negatively skewed with a possible outlier. Okay. So we'll go through and we'll get rid of a couple of things to start with. So first one is it's not bimodal. So bimodal means two modes, right? And if you think back to what mode means, it means the most common or most frequent value. So it's not bimodal unless it has two pinnacles of the same height or two columns at the top at the same height. So it's not bimodal. I wouldn't call that symmetrical. So it's either positively, negatively skewed, or negatively skewed with a possible outlier. Yes, hello. So when I'm doing the stream in front of an open window, everybody wants to wave at me. So I guess we've got to figure out which one that is. Okay. So if you think back when we were talking about skewedness, I guess, ideally what you want to see when you look at a distribution is you want to see a clean sort of distribution, right? Where everything sort of bunches up around a middle section. If in this case we're looking at skewedness, we look at if, like, I guess what side is pulling the data and what side is affecting the data, right? One thing that's worth pointing out is that looks like a possible outlier as well. So yeah. So what I would say is I would probably say that the data's here. It's probably being skewed to the negative side. So I would say E, negatively skewed with an outlier. Okay, I probably got that wrong. I have to double check my notes. So this is the problem when I'm doing an exam. I don't bring any notes with me and I forget things. So just let me double check that before I jump into the next bit. You might be this one. So I've got them around the wrong way. Okay, so it's positively skewed. Sorry. So even teachers make mistakes. So that one's positively skewed, as you might be able to see from my notes here. Which makes sense because the data's trailing off to the positive end, so that's skewing the data there. Okay. Yeah. So check that. Correct answer is positively skewed. That's why it's important to bring notes into your exam. Okay. If 4,000 people were in the sample, how many people had salaries between 45,000 and 55,000? That's this bracket here, 45 to 55. So I guess we'd be looking at like, that's what, 20%? So 20% of 4,000 is the same as 1/5 of 4,000, which equals 800. So that's C. Okay. So yeah, too easy. C. Let's move on to the next one. All right, but dot plots, exciting stuff. So we're looking at. Let me try and get that into screen a bit better. Okay. The dot plot below shows the number of children in 15 families in a suburb. What percentage of families have at least one child? So for those of you who watch the stream on Monday, you might have already heard me talk about this, but these sort of questions are thrown in all the time, and it's important to interpret what at least one means, right? Because basically the question is, does it mean one or more, or does it mean greater than one, right? We've got to figure out what's the question actually asking. If it says at least one, that means one or more. More has an E on the end, right? So I'm basically looking at everything except for these two data points here, right? So families that have at least one or more is 13 out of 15, which is, I think it's 87%, but let's double check that. On the CAS, on the wrong screen. 13 out of 15. Thank you, CAS. Yeah, 87%. So that's B, right? And even if you weren't too sure how to do that process, you could look at this and say that it's definitely more than 20%. It's more than 2/3. It's not 100%. You'd be left with B or E. And even if you don't know how to do that, it's a 50% chance that you can guess and get it right, which is, you know, an improvement. So on my other screen, I've gone back to the start by accident. All right. So let's scroll down. Make sure that's in screen. So now we have a back-to-back stem and leaf plot. We're looking at two classes scores on a math test. So we have Class A and Class B. Give me for a second. Class A and Class B. And they're the distributions either side there. And we're asked the median percentage marks scored by a student in Class A is, right? That's just a roundabout way of asking what's the median of Class A, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values, right? Which means if we're looking for the middle value, we're looking between 7 and 8 because we got the middle value is 7.5. So if we go 1, 2, 3, 4, 5, 6, 7, 8, we're looking in the middle there. So it becomes 90.5. All right, so 90.5%, which is A. All right, that wasn't too bad. Next we got Class B. It says the IQR of Class B is what? So again, we're going to have to find that middle range. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which means we're looking for the 7.5 to be the median. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 75.5 is the median. And now if you remember, if we're looking for IQR, we're looking for the median of each half and finding the distance between those two. All right, so of this half we have 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 divided by 2 means the fourth value will be the median of the lower half. So that's 1, 2, 3, 4, so 71. And then our upper half is the fourth value too. So we have 1, 2, 3, 4, we have 85. So 85 minus 71 gives us 14, which is an answer, which is good. That's how you do IQR. So it's a little bit tricky, so make sure you have the rule for IQR written down, which is Q3 minus Q1, right? And then to find Q3 and Q1, you find the median to find the middle, and then the median of each half of that will give you the IQR. So that's that one. Oh, I'm still going to need this data set for the next page. All right. So it says the mean and standard deviation of Class A are. All right. So if I want to find that, I'll need to put it into my lists and spreadsheets. Class A, I'm just going to enter this value in quickly. So if you're watching at home, take this opportunity to have a drink or get some food or whatever, because this will take me a minute just to enter in all this data. Where am I looking? Over here. Alright, 2 kids got 100. Cool. Alright, we're back. So all the data's entered. So it's asking me to find the mean and standard deviation. So to do that, I go menu, statistics, stat calculations, one variable statistics, because we're only looking at column A. and this will spit out a whole bunch of info here. All right, so we're looking for mean and standard deviation. So mean is represented by this x bar value, right? So x bar is 85.7. So I can already rule out 1, 2, right? It's not B or E. And then next, my standard deviation is 12.64. Right, so 85.7 and 12.64. So it's that one, not that one, not that one. All right, and the reason it's not 6.3 is because you've got to round up to 2 decimal places. Okay, says the correlation coefficient of negative 0.68 describes the relationship between two numerical variables as. So again, think back to the last stream, I talked about how you should have that table in which talks about the correlation coefficient and what that means in terms of strength and direction. If you do have that table, you would know that a negative 0.68 would describe a moderate negative association. So that's this one here. And even if you didn't know that, like I said, you can start to rule out questions. You could say that it's definitely not positive, and you would assume that it's linear. There's nothing in there to suggest that it's non-linear, so you can get rid of those two. So you sort of get left with either A or C, and again, it's a 50-50 toss-up between those two. You'd probably assume that because it's not super strong, it's probably not, it's not a high number. So, yeah. Alright, we're done with that now, and that data. We'll go to this one, which talks about least squares regression line. It says that the least squares regression line that predicts the salary of managers from their age is given by this equation underneath. And it says from this equation, we can say that on average, which of these things? So on average, we can say that the salary stays at that value. Well, that's not true, because when there's an increase in age, that value is going to go up by a bit. So it's not A. Salary increases by 6,978 each year. Well, it makes sense, because if you go up an age each year, that one, I'm pretty happy with that one. So I should probably circle that. The salary increases by 20,000 each year. Well, that's not true. Salary decreases. That's not true. Well, neither of those could possibly be true, because the salary decreasing means the more time you spend with the company, you lose money. That's a dumb way to do things. So it has to be B, right? It has to be B. Okay, in a scatter plot, y versus x, the correlation coefficient is used to find. Is this a bit hard to read? Mind. Bring this down a little bit. It's a little hard to read. Alright. So in a scatter plot, the correlation coefficient, what's that used for? Right? So you could say that what's its purpose? So I guess we're looking at, you're trying to find either a specific value of the y variable given the specific value of an x. Probably no, that doesn't sound right to me. It sounds like what do you call it? Least squares regression line. A specific value of x given a specific value of y. Well, that's wrong too. Can't be that, because again, that's a regression line. The strength of the relationship between the x and y variables, I'm pretty happy with that. The slope of the regression line, well, no. And the dependent variable, no, it's not that either. So it has to be C. So the slope of the regression line is the m value in the regression line, and the dependent variable is the one that is affected by the independent variable. But we don't even cover that language anymore, so don't stress too much about that. We'd use something else instead. Let's get rid of that. And we have the association between x and y in the scatter plot can be described as, well, that looks negative to me because it's going downwards, right? So yeah, it's going in a negative direction, first of all. And I would say that's pretty strong because it's staying fairly consistent. So I would say that's a strong negative linear association. Right? So it's not positive, so you can rule them out. It's strong, it's not weak, and it's definitely linear. Non-linear has to be all over the place to be, yeah, considered that. Okay, next question. The following table shows the hours spent by students in a lab before an exam, and then their grade as a percentage of that. All right, or their grade given that time. The least squares regression line for the above data is, okay, so I'm going to have to, I can rule out a couple of ones straight away. So we need to figure out which is the y and which is the x. Remember that the x explains the change in y. So I would say that x is hours spent in lab, because that would explain the change in the grade. Alright, so we want it to be in the form of hours equals m times grade. No, other way around. Grade equals m times hours. Alright, that makes sense because hours explains the grade. So in that case, we know that it's not B and it's not E. We just got to figure out which one of these it actually is. So let's we'll open a new document with some spreadsheets, and we'll have H for hours. Okay. And we'll have G for grade. So give me a second to type in this data. Okay, so I have those two values there, those two columns there that I've entered in. And now if I want to find the regression line, I would go to Menu, Stats, Stat Calculations, Linear Regression. Remember my X is hours and my Y is G, or grade. And that will give me these values here. So it says that it's going to be y equals negative 1.86 times x plus 88.63. So we got negative 1.86 times hours plus 88.63. Alright, so I look at that and I know that it's not D, it's definitely not D. So it has to be one of these two. But if you notice, this isn't in the form that I just wrote it down in, which is a bit confusing. But there's a law in mathematics called the commutative law, which means that if you plus two statements together, you can actually change the order of that and they won't matter as long as you take the sign with them. So this is the exact same as this. Alright? Which looks like one of these. Which looks like this one. So it's not C, it's A. Alright? Second says the value of the Pearson's correlation coefficient R for the data set is. So Pearson's correlation coefficient is R, which is negative 0.34 or negative 0.335, which is this one here. All right. And I just got that straight from my CAS, which is nice and easy. That's the end of the data section. We'll move on to matrices, which is always a bit more fun for me. That's good. All right, first question. Matrix 1001 is a, well, we should already know the answer to that one, but we can say that it's not a row or a column matrix because it's not just rows and it's not just columns. It's got multiple rows and columns. Could be diagonal, could be identity. It's definitely not zero because that's just got zeros in it. But this is an example of an identity matrix, which hopefully some of you guys have figured out. An identity matrix is this one. A diagonal is the exact same, except instead of these values, there's something else other than 1. So there might be 0.5, for example. If matrix A equals this, element 3, 1 is, so that's row 3, column 1. So go down here, row 3, column 1 should be 2. Nice and easy, can't complain about that. Then we have the solution to the following equation is, we have 2, negative 1, negative 5, 4, plus 3, negative 3, negative 2, 0. So I'm just going to plus these values together and just eliminate things one at a time. So 2 plus 3 is 5. Does that get rid of any? No. Negative 3 plus negative 1 plus negative 3 becomes negative 4. So I can get rid of these two. Negative 5 plus negative 2 becomes negative 7. I can get rid of that one and that one. So it must be E. There you go. I didn't even need to finish doing the whole thing and I can figure that out. Oh, I just realised you couldn't see that. Let me move it up a bit so you can see what I did. So last time I was doing this, there were some people that were in the chat telling me when I wasn't doing this properly. Yeah, so all I was doing was passing these values together to get these, and it helped me rule out things. Okay. All right. This one's quite a big question, so I might need to move the camera up. All right. So it says an adjacency matrix that represents this diagram below. All right. There's a bit going on here. So what I'm going to look for first is this funky little E over to the side means E connects to itself and nothing else. All right. So I want to look for if E is touching or has a 1 in the column for E and zeros in everything else. So if you see this one, this value is 0, so that's wrong. That value is 1, so it's okay. This one's 0, so that's wrong. And that E to E is also 0. So it has to be B or D. Right? I can rule that out automatically, which is good. Because even now, if I can't go any further than this, I've got a 50-50, which is all you really want to do. If you can get every question down to a 50-50, then if you just guess, if you fail, it just means you're unlucky. Not so much that you that you can't figure it out. Okay, so we got that. So what's the difference between these ones? A to A here is 3, A to A here is 0. So how many times does A connect to itself? Well, it doesn't. So that means B has to be the answer. It means D's wrong. Alright? And that was a lot easier than actually drawing out the whole matrix. So much quicker to just rule out questions rather than solve the whole thing. I'm blitzing through this. I'm going to be a lot shorter than the last one, which is nice for you guys, I guess. Alright. This time I'm doing a matrix subtraction. Let me fix that up again. Okay. So again, I'm just going to do these and then rule things out as we go. So -2 minus -2 becomes a plus. So that means -2 plus 2 equals 0. So the first value is 0, which means it's not that or that. Okay. Second one, -2 minus 6 becomes -8. Oop, I forgot how to write all of a sudden. Is there a -8? Well, where did I get that from? Hang on. So it's 3 minus 6. Should be -3. Forgot how to do maths as well. So this value should be -3. So it's not E. So it must be B or C. And the difference between B and C is this last value here. So I'm going to skip. I'm going to assume that one's 7. And the difference between these, so it's 1 minus -3. So 1 minus -3 becomes a positive, which means 1 plus 3, so it's 4, which means it's that one. Okay, so again, that's a bit of algebra, directed numbers. Hopefully that wasn't too bad. Okay, so if 2m, okay, so 2 multiplied by that matrix minus that one equals this, then what's m? That's a good question. So I guess in order to do this, we're just going to make an algebraic equation. So if I multiply all the values in here by 2, that becomes 2m minus, and then minus away 5 equals 7. That's not even really a matrix question. It's like an algebra question. So if I plus 7 to both sides, 7. If I plus 5 to both sides, get 2m equals 12, which means m equals 6 if I divide both sides by 2. So D is my correct answer. Okay. Alternatively, what you could do is sub these in one at a time and say 2 times 1 minus 5. No, that's not 5, yeah, and cross things off that way, but that's the right way to do it. Yeah. Okay. Next question. At the footy, Pete bought 3 pies, 2 hot dogs and 4 buckets of chips. At the footy, pies cost $4.50, hot dogs cost $3.70 and chips cost $4.20. The matrix product that gives the amount Pete spent on food at the footy is. Alright, so we want, if we want to find the total amount, we want a matrix that ends as a 1 by 1 that just has the amount spent, right? Which means that if we're multiplying 2 matrices together, remember if we have m times n and n times p, if the values in the middle are the same, then these values become the answer. So if we want a 1 by 1 as our answer, we know that it has to be a 1 by something matrix and a something by 1 matrix. Alright? So the first one needs to have only one row. So the first matrix has only one row, so I can cross this off because that's got 3, and cross that off because that's got 3. This one they're also plussing values together, which is wrong, so I'll get rid of that. So it's either A or E. Alright? So it's a 1 by 3, which means that my other matrix needs to be a 3 by 1. And that's not a 3 by 1, that's another 1 by 3. It can't be that, it has to be E. Alright, and that's just using some logic. Alright. Next page. I'll take you back to the top. So we have the determinant of matrix A. So A is equal to a half times this matrix. This is a little bit complicated because this is sort of like a 2-step one. So all we have to do is we have to put a half into here. That'll give us 0.5, 2, 1.5 and negative 2.5. And then remember, the formula for the determinant is A times D minus B times C. And if you're not sure about that, these are where you get the values from, right? So A is 0.5, so a half times D, which is 2.5, minus B is 2 times C, which is 1.5. Did I do that right? Oh shoot, I gotta swap these values around. Sorry, that's my mistake. So you gotta change them from this when you're doing an inverse to, oh no, that shouldn't matter. No, it's fine. Okay, so a half times 2.5, we bring this back into shot, minus 2 times 1.5. Alright? So what that'll give us is a half of 2.5, which is 1.25, minus 2 times 1.5, which is 3. Alright, so 1.25 minus 3 gives me negative 1.75. I think. Negative 1.75. Did I do that right? Hang on. So if that's negative 2.5, this becomes a negative value. So that's a negative value. So it's minus, so it should be negative 4.25. So it's that one. Alright, that was a little bit of a complicated question, so if that spooked you out, I apologise. Yeah, it wasn't too bad in the end. I just stuffed around for a little bit. Alright. Using matrices to solve a set of simultaneous equations. Matrix 16 over 9 is multiplied by which of the following matrix to make the values of x and y? Okay, so the process of simultaneous equations is that you have the values here. So you put in your values from the equation multiplied by one that has the variables equals one that has the answer, right? And then what happens is you find the inverse of this one and multiply by this one. So what they're asking is, what do you multiply this by to get the answers? Which is basically a roundabout way of saying, what's the inverse of that? So let's do that. So to find inverse, we have 1 divided by the determinant. And we'll have 2, oh no, we've got to swap these around, so it's 7 and 2. And then we swap the signs of the other values. So it becomes 3 and negative 1. Alright, I'll do this on the CAS because it'll be a little bit quicker. So there's a button here under the delete key. Maybe I'll make it a little bit bigger for this. Alright, so there's a button here under the delete key. You select that and you can pick your matrix size. So I'm just going to have a 2 by 2. And we have 2, negative 3, 1 and 7. And to find the inverse, we just raise that to the power of negative 1. And that gives us that value there, which is a little bit complicated. So we've got everything over 17. Okay. This is interesting because we got all these values here over 17. And that's obviously not going to match anything that we have here. So let's go back a step, right? So if it was originally going to be 1 over the determinant, I'm assuming that the determinant is 17 from these values that we have here, but we can double check it. So it'll be 7 times 2, which is 14, minus 3 times 1, minus negative 3 times 1. So that will be a determinant of 1 over 17. So that means that in order to get this step here, that we've had to multiply all their values inside by 17. So our values should actually be 7, 3, -1, and 2. So is that here? Right there. That's a complicated way of figuring it out. I think if we went down the process of finding it by hand, it would have been a bit more obvious. Let me again minimize that CAS because it's in the way of the answer that I circled. So I think if we went the way of solving it by hand, that would be more obvious, but that's a good question. It was tricky. Last one. I probably won't need a CAS for this either, so alright. The system of simultaneous equations below can be represented in the form of. Okay. So if we were to put this into simultaneous form, it would be in 2, 1, -1, 3, -1, 3, 0, -1, because there's no x. Far out. Let me start that again. 2, 1, -1, 0, 3, -1, and we got 5, there's no y, and 3. Okay. Multiplied by x, y, and z. Gives us our answers. So is that here? 2, 1, -1, 0, 3, -1, 0, 5, so it's not that one. 2, 1, -1, 0, 3, -1, 5, 0, 3. Could be that. 2, 1, -1, 0, 3, -1, 5, 0. No, it's not that. We have 2, 1, -1, 0, 3, -1, 5, 3. So it's not that. And we have 2, 1, -1, 0, 3, -1, 5, 0, 3. So it could be that. So it's either of these two. Oh, but you can see the issue that they've got here now is that they're multiplying this by the answers and not by the pronumerals. So it's not B, which means it's E. And that's it. That's all I had to do. So that was good. We managed to smash that out in 40 minutes. So for the couple of you that actually stuck around and watched that whole thing, I really appreciate it. I hope you got something useful out of it. You were awfully quiet in the chat, didn't really have much to say, but you know, hopefully you enjoyed, and I'm assuming that the rest, hopefully more people are going to watch this before you go into your multiple choice exam next week. You know, because it is a fair bit of time that goes into putting this all together. So it's a bit discouraging when not many people watch it. But anyway, for those of you who did, I really appreciate it. Good luck with the rest of your exams. Come see me if you need any help. Okay, bye.